So like I said, we're looking at logarithms. So logarithmic form, how you would read this is log base b of a equals x. We're going to see that this little number we call the base, like by a logarithm. You'll see sometimes you have one, sometimes you don't. To rewrite this in exponential form, you take your base. You remember the base is what you raise to a power as well, like from what we've talked about before. But you would have b up to the x power equals your a. So we're going to basically, a lot of what we're going to look at today is like either we're going to have something in logarithmic form and we'll turn it into exponential form, but you could also change exponential form into logarithmic form. But basically you take your base up to what it equals on the other side of the equal sign, and that's going to give you your a, or like basically what you're plugging in. So basically today I just want you to kind of get used to it. There's different ways. I know there's some, like, I don't have like one off the top of my head, but if we're having ever trouble, there are kind of like clever ways. I know teachers teach you to kind of remember how you do this. I'm trying to think. I've heard one before. Maybe I'll try and look up, like, I know there's kind of like some mnemonic devices or kind of like catchy sayings to kind of remember how to rewrite this, but for example, like one type of problem we're going to see a lot of is just rewriting these equations in exponential form. So like I said, you take your base, so that would be 3 up to what is after the equal sign, that's your power, and that's going to equal 9. And you can see this is true. I mean, 3 squared equals 9. We'll see sometimes if you have a variable, you'll be solving, but I mean, this, we're just rewriting it. So this is obviously true. For number 2, you take your base 6 up to 3, which would be your power, and that's going to equal to 16. And if you put that, if you don't know, like, I mean, I don't know 6 to the 3rd power off the top of my head. I mean, I could multiply it out and think about it, but if you verify that would also be true. So I mean, like when you're rewriting it, I mean, a lot of times you can kind of just, or is what you're writing make sense? Like, I mean, if you put 3 up to the 6th power, or you did 6 up to the 216 equals, like, I mean, it's just not even going to make sense. But maybe if it helps with these labels, so like, I mean, obviously your b is your base, and like your x is like your power or your exponent. Like that kind of helps you with the labels, and then a is what it's going to be equivalent to. So this one, I mean, you would see you have 7 up to the 0 power equals 1, which would also be true. Remember, anything up to the 0 power is equal to 1. What about for number 4? How would we rewrite this in exponential form? You want to try 4, or I mean, any of these, like 5 and 6, but like what would 4 be, just to kind of make sure you're seeing how to rewrite this? Flip, but remember the base goes like, is your, the 2 is going to be your base, so 2 up to the 4th. Oh, did you? Okay, I think you said it backwards then. Maybe you wrote it right. I don't know if you guys can see the chat in the class, but okay, so just to kind of, if you want to check yourself, but good for anyone that sent me your answer, but 2 is your base, so it'd be 2 up to the 4th power equals 16. And you could verify that is true. Like I said, this is just a way to rewrite it. So I mean, like what you get is obviously going to be equivalent, or it, like you shouldn't create like a false statement. So similar idea. I mean, 4 up to the -2nd would equal 1/16. That's a good thing to keep in mind. Anytime you're going to have your answer equal a fraction, like if you have a fraction plugged in for your a, like into a logarithm, you're going to get a negative answer for your power. So then same idea here, 9 up to the 3/2 equals 27. Remember, when you have a fractional exponent, like that would be, like you could either take that up to the 3rd power or square root it first. So I mean, if you square rooted 9, that would be 3. 3 up to the 3rd power would be 27. You could also do 9 up to the 3rd power. What would that be? So that's 700 something. If you did 9 up to the 3rd power, that's 729. The square root of 729 is 27. So like either, like when you have a fractional exponent, you could do either order, but usually you want to do the radical or the root part first, because then you'll get a smaller number as long as it works out okay. So that's how you rewrite it in exponential form. Now we're going to kind of just go the other way. We're going to rewrite something that's in exponential form into logarithmic form. So just being able to convert between these can be kind of a nice thing, or it's a type of question you could see depending on what you're doing. But remember, our general form, or I should have wrote that. Like our x, I'm just going to rewrite what we had here, but your general form was this. To get it in logarithmic form, just remember it's log. Your base goes like is your kind of small number, like your, what do they call that? It's the words gonna escape me, and then a equals x. So like for this first one, you're gonna have your base is 14. So you're gonna have log base 14 of 196. Am I doing that right? Equals 2. Yeah, because if you did it the other way, it'd be 14 squared equals 196. So sorry. So remember, this is your base. The power is your x. And then this is like your a value, or basically what would be plugged into the log function. Let's just do a couple. I'll do a couple and then let you try some. But like I said, nothing too crazy here. Same idea. So this would be log base 3 of 81 equals the power, which is 4. And you could always, like, I mean, if you're good at going one direction, you could always check if you did the reverse. This would be 3 up to the 4th power equals 81. Looked at the log. So similar idea, this would be log base 12 of 12 equals 1. So maybe if you guys want to, here, maybe I'll do this one because it's a fraction, because it's hard to type, but this would be log base 36 of 6 equals 1/2. So maybe if you guys want to try 11 and 12, just make sure you can get it in these forms, but nothing too crazy. And like I said, I mean, we're not really doing anything with these now, but we'll see eventually in the future. Sometimes it's nice if you can kind of change between forms. Sometimes it's nice to get it into log form because there's different properties that you can kind of combine or condense logarithms. So eventually we'll get into some applications, but for today, I just kind of introduce into like how to change these. I mean, from what I'm seeing, I mean, you guys are feeling all right about this, right? In person. Okay. So let's just go over. So, I mean, from what I'm seeing in the chat, looks good. So this would be log base. Oh, what am I doing? Log base 2 of 1/8 equals our power of -3. And then for this one, you would have log base of 8 of 16 equals our power of 4/3. So that's just how you convert. So from one form to the other, that's the idea. I'll see if I can even find like a little video that maybe explains it better than how I am right now. But nothing too crazy, but there's definitely maybe some ways to maybe help you kind of remember how to do this. So one thing when we're talking about logarithms, it's called a common logarithm, or some people just call it like just the base logarithm, but a logarithm with base 10 is called a common logarithm and can be written without a base. So if you ever see just log, like, or if you look at your calculator, like your log button is log base 10. Like, so if you don't see a base, just assume it's base 10. Because a lot of things, I mean, it's just nice to kind of make that the common log, because a lot of, remember, this is a way to write different forms of exponents. So like a lot of times you'll deal with factors of 10, like hundreds, thousands, 10,000. Like, so it's just like, it comes up a lot. So that's why it's kind of like the common base. In our number system, we have a base 10 number system, like each space in our number system. So that's why it's 10. So the next thing we're going to kind of look at is just evaluating logarithms. If you kind of remember from our log form, this is going to be equal to x. Basically, we're trying to figure out what this equals. So when you do this, you say, like, basically, if you're trying to evaluate a logarithm, you're going to take your base, and you're asking, what would I have to take my base up to get that number I'm plugging into this function? So 7 up to what power equals 49? Should be pretty easy just to see that, oh, that would be a 2, because 7 squared would be 49. So same idea with the, like when you evaluate a logarithm, you basically take your base up to x, or you're trying to figure out what the power would be to make it equal what you're plugging in. So 3 up to what power would be 27. And if you don't see it right away, I mean, you could kind of plug and chug into your calculator. So this would be 3, like 3 to the third power is 27. This one, remember, if there's no base, your base is 10. So this would be 10 up to what power equals 100? That would be 2. And if you have a graphing calculator, since that's like a log base 10, I'll show you how you can do different bases in your calculator. But if you put in your calculator log of 100, like you would get 2. Like if you have a graphing calculator in front of you. But that, like if you have a calculator that has a log, but I don't know, like I don't think your phone calculators would probably have it. If maybe if you turn it sideways, I'm not sure. But this one, 12 up to what power would equal 1? Remember, what do you raise something by that always equals 1? What's that special power? Like what would our x be like in number 16? 0, right? Remember, anything up to the 0 power is 1. So if you ever have like a 1 plugged in, like your a in this general form, like what's like the big number with your log, that's basically what you're plugging into that function. So I mean, if you ever see a 1 there, it's always going to be 0. Like doesn't matter what the base is. For 17, 2 up to what power equals 64? Like I said, if you don't know it off the top of your head, I mean, you could kind of plug some numbers in your calculator. Like just like if you don't, like 2 up to the 5th power is 32. So 2 up to the 6th power is 64. But so it would be 6. But don't be afraid to like kind of guess and check a little bit in your calculator. I mean, the more problems you do, hopefully most of these you can kind of recognize or at least have a really good idea. Maybe it takes a couple guesses. I mean, you shouldn't be guessing 50 things in your calculator, hopefully, but if you need to, I guess it's not that bad. But 3 up to the x equals 243. So I'm not sure. I mean, I'm just going to plug in. So maybe 3 up to the 7th. Nope, way too big. 3 up to the 5th, maybe. Yep, got it on my second try. So, I mean, the more you see, the better ideas you'll kind of have based on your number sense. But that would be 5 if you plug it in. Keep in mind, anytime you have it's going to equal a fraction. Remember, you're going to have a negative power. So you really want to ask yourself 9 to what power equals 81. Let me see. Oh, 17, 6. Isn't 2 up to the 6th power 64? Yeah, Aslan, sorry. 17 was 6 because 2 up to the 6th power is 64. You might have to kind of guess and check in your calculator if you don't see that. But like I've like, for example, when I was trying, I did 2 up to the 5th power, I got 32. So then I just tried 2 up to the 6th, and that was 64. But so, like I said, especially when you get some bigger numbers, or especially if it's like, I mean, perfect squares, you'll probably recognize very easily, but sometimes it's harder when you got like 5th, 6th. But sorry, back on number 19, I got a little bit sidetracked, but let's go good. You want to ask yourself what power would give you 81? So that would be 2, but since it's the reciprocal or flip, this would be negative 2. Remember, anytime you have a fraction like 1 over something, you're going to have a negative exponent to flip it, and then think about what power would give you that 81. Similar, and these can be kind of tricky, but for this one, you'd have 64 up to what power equals 4. So that's going to be not a negative exponent because it's not like flipping it. That's going to be a fraction exponent because it's almost like you took a root. So what type of root would equal 4. It's not the square root. The square root would give you 8. My guess is it's the fourth root, because 4 times 4 times 4 times 4 would be 64. So I don't know if this one makes sense for 20, but it'd be 1 over 4. Basically, you would take the fourth root of 64 to get 4. So sometimes if you notice your answer gets smaller, not like that it flips as a fraction, you're basically taking a root. And you could even have a mixed fraction. Like, for example, maybe you have to raise it to a power and then cube root it. These ones can be harder to see for sure. Is it 1/3? Maybe I did that wrong. Oh, wait. Yeah, you're right, because fourth root's too much. Sorry, I did that wrong in my head. You're absolutely right. It would be the third root, because 4 times 4 times 4 is 64, not 4 fourths. So thank you for catching that, Mikhail, though. But yes, and you could always plug this in your calculator, like 64 up to parentheses 1 divided by 3. You would see it's 4. Like this is how I would type it in my calculator. But it's really important you put the parentheses, but you would see that that's 4. And you could kind of guess and check. Like, let's say that didn't work, try 1/2. That would be like a square root. Try the fourth root. If not, sometimes it might even be like a mixed fraction, which maybe we'll kind of deal with getting better with those. But those are hard to see, and it might take a little bit of guessing and checking if you're not familiar with it. Like even myself, I just goofed up on that one. Like, it's hard when you get fractional exponents to recognize them off the top of your head. Like, so for these, I've been basically showing you how to evaluate these in your basically by hand, which for most of these you really should be able to do. But sometimes, like, all these ones are working out nicely. So sometimes your answers might be like fractions or decimals, right? So I want to kind of give you a tool to evaluate this. So this would work with a graphing calculator, or I'll show you with like the calculator I have on my iPad here. But to evaluate a logarithm, like if you want to put this in your calculator, like maybe you can't, maybe you just couldn't think of an answer. Like, I mean, or maybe it's one of those fractional exponent ones that are kind of hard to think of off the top of your head. Here's how you do it in your calculator. You use this, it's called the change of base formula. You're gonna do, oh crap, let me Google this. Let me pause the recording. I can't remember if it's either log base A. All right, but your change of base formula, you take the log of your A over the log of your base. So like, remember, A is like what you're plugging into your log, and then B is obviously your base, or the small number. So if you wanted to evaluate log base 16 of 64, like let's say you couldn't think 16 up to what power equals 64, maybe you just can't figure it out like in your head. Here's how you would put in your calculator. I mean, you would just do log of 64 divided by log of 16, not 60. So I'll kind of pull up my graphing calculator really quick. Or if you have an actual graphing calculator, I mean, you would just do this. But we're going to do log of 64 divided by log of 16. And if you see, the log button is like right left of the 7. But our answer would be 1.5. So, because this is kind of maybe a hard one to see, 16 up to the 3/2 equals 64. And like I said, that's hard to kind of recognize all the time. Like, I mean, unless you're just really good, like, I mean, like with your mental math, you could kind of try some things in your head really quick. But honestly, that's something I would use. I would pull in a calculator for if I needed to figure out, like, I mean, unless I just saw it. But so if you like, so just to kind of reiterate, I showed you a bunch of these we could do by hand, and you really should try and do them by hand when you get simple ones. But if you can't figure out what it is, if it's like a decimal, or maybe it just doesn't work out nice, you want to use this change of base formula, and you can plug it in your calculator. So like this one, you would do log of your A, so log of 32 over log of 8. You would just put this in your calculator. And just be careful when you put it in your calculator. You want to, I like to just put equals and then divide it. I mean, if you try and put it in all at once, you really want to make sure you close your parentheses, but this would be 1.66. Remember, you can change it into a fraction if you'd like. So that'd be 5/3. If you don't, I mean, some of those you could just see, but that would be 5/3. which would have been hard to see, like 8 up to the 5/3 equals 32. Like I don't think I would have been able to easily have figured that out um, without this. So if you guys want to maybe try number 23 or 24 on your own really quick, I don't know if I'm going to do all these. I mean, these are all the same process.